My name is Justin Shen.
Hi, my name is Melanie Nair.
Hi, my name is Joshua Lee.
Hello chemistry students. Today we're going to be learning about the freezing point depression lab. And we're going to be teaching you how to set up the lab. So first off, what do we have here?
So in these two test tubes, we have a pure lauric acid sample and a sample mixture of lauric acid and citric acid.
And practically this lab is used to determine the freezing point depression of both these samples and at what temperatures they freeze.
So we are going to find the freezing point depression of this mixture.
And we're going to do that by boiling this this mixture into a liquid so that we can test it out by putting it into a room temperature water in order to find out what the freezing point depression is. And what we have here, we have two 300 milliliters of tap water, one at room temperature, and we have another one boiling on the hot plate. And what we also have here is a clamp ready to hold on to our temperature probe, and that is plugged into our spark.
So right now we're just melting the samples, and then what you are going to want to do after that is during the actual lab, you're going to take the melted sample, put it into the room temperature water, and you're going to put a temperature probe in it, and it's going to freeze again, and you're going to take a graph. So to find the graph, you have this spark.
So what we're going to do is we're going to be putting our temperature probe into our spark. So we're going to grab our temperature probe, and your home screen should look like that. So you're going to open up, or not open up, but you're just going to look towards the top of your spark and plug this in, and then you see this temperature.
You're going to select the temperature and then click show. And it's going to show a graph, so when you actually start collecting your data, you can press this green button and it will graph the temperature for you.
And if you want to be even more specific with the temperature, you can press the top right arrow button, or whatever, and then it will display even a more accurate measurement of degrees Celsius.
You can switch back and forth between the different kinds of data collection methods, but it's gonna show the same data.
In the end, it always shows the same data.
First, we'll start off with some definitions of key terms used throughout the lab.
Right, so the words we need to find are molar mass, molality, freezing point, vapor pressure, solvents, colligative properties, and the Van Hoff factor.
The solute in a solution is a substance dissolved in a solution. Also, it has less concentration than the solvent in the solution. The solvent makes up the majority of the solution and is dissolving the solute in the solution.
Alright. Molar mass is the amount of mass contained in 1 mole of an element or compound expressed in grams. These are defined right on the periodic table. They are basically the average of the masses of isotopes that the element can become.
So the molarity is essentially the concentration of a substance. It is determined by getting the moles of a solute, which is what is being dissolved, and dividing that over the liters of the solution. Remember the Brita?
But molality is different. Molality is determined by getting the moles of solute and dividing it over the kilograms of the solvent, or what is doing the dissolving. Molarity and molality have a unique difference between them, however. Molarity is dependent on temperature, while molality is not. That's why we're using molality instead of molarity for this experiment.
The freezing point is the point at which a substance will freeze, hence the name. This is the temperature at which the substance will change from a liquid to a solid. This next one isn't necessarily you have to know for the lab, but the boiling point is similar in a way. It's the temperature at which a substance will change from a liquid to a gas.
The vapor pressure is the pressure of the vapor in a closed container at equilibrium. This occurs because in a closed container, the surface particles of a liquid initially shift to a vapor through evaporation. After a while, the vapor that is present begins to condense as well. Eventually, the system reaches equilibrium.
Equilibrium properties are properties assigned to solutions dependent of the amount of solute in the solution and not the identity of the solute. These would include freezing point depression and boiling point elevation.
And finally, the Van Hoff factor is defined as the relationship between the moles of solute dissolved and the moles of ions in solution. Essentially, the number of ions that a compound would separate into from one formula unit of the solute.
Go. Alright, first thing we have to check in any lab is safety. And with goggles, any scientist can look beautiful and sexy. So, starting part 1 of our lab is determining the freezing temperature of pure lauric acid.
Which is?
This right here.
That's
As you can
right
see,
there.
we have melted the solid into a
Liquid.
solution. So, for this lab, we had to make sure that this temperature probe was on one of the utility plants, and we had this little beaker of 300 milliliters and a 400 milliliter beaker.
That is tap water, by the way.
Yeah, nothing new. It just has to be colder than this because this is making it liquid and we want to make solid. Let's start.
Freeze it.
Yeah.
So, using the clamp, you want to clamp that test tube so that it's kind of floating in that beaker. Warning. Don't let that stuff spill on you. Seriously. Don't let it. And
Don't wanna die.
You don't want to die. You don't want to have to redo this. You don't want to be seriously injured. And don't touch the bottom of that test tube. We're warning you. Hey,
Because
bad
you
idea.
will ruin your data. So, now you can just start the data table. Start, and then it's going right now. As you can see, the liquid is going to be turning into a solid already because it's meeting its freezing point. And we're just going to determine that once we get to the post-lab, which is
Later.
so now we just wait.
Wait. Okay, so now the lauric acid is filled.
But remember, this is important. You need to move the temperature probe so that you are slightly mixing the solution.
Stirring.
Yes, stirring the solution because there's nothing to mix it with. And once it is turned solid as such, you don't want to remove the temperature probe yet because the temperature probe has some lauric acid on it.
Plus it might be stuck there because it's in focus. You never know.
Yeah, you never know. You want to be
You
safe.
might just have bad luck.
Exactly.
What the hell are you doing? Yeah.
Teamwork here.
I said we stop with minis.
Both 1 and 8.
Or was this last? After I talk, we stop. Yeah, so it's 37. By the fridge.
Frozen, as you can see.
Now we let it sit in there.
Yeah, we can.
We can stop collecting data at this point.
As you can see, I've stopped the graph. Oh.
Stop talking.
You want to make sure that you correctly have started or stopped the graph.
Yes.
Hi, my name is you.
Okay.
Michael, you.
Now, you want to carefully remove the temperature probe once it has melted. And wipe off any excess with the paper towel. Wipe excess off with the paper towel.
Why? No, we can't get through that part.
You don't want to be collecting data right now because you don't want to be... Okay.
Screw you up.
Yeah.
Seriously.
The freezing temperature can be determined by finding the mean temperature in the portion of the graph with nearly constant temperature.
Hi, my name is you, Michael, and you're with.
Now, select the data in the flat region of the graph. Find the mean temperature of the selected data, record this value. Store the data so it can be accessed later and you never can be too careful. So make sure you save everything onto a flash drive or maybe when you're done, put it back into the computer.
Michael, you, and here with.
Okay.
Why would y'all my
We're just showing later.
We will show you.
Find part 2 of the lab, which is basically determining the freezing temperature of a solution of benzoic acid and lauric acid. But the difference here is that we could not. We can't.
And today we'll be showing.
We can't. You don't.
transition.
Now we'll be starting part 2 of the lab, which is determining the freezing point of a solution of benzoic acid and lauric acid. Now, since benzoic acid would not work in this lab, Mr. Zunas gave us
Solid
citric acid. Citric acid. Citric acid.
Citric acid, not
Citric
nitric
acid.
acid. Not nitric acid.
So,
When you start building the model,
we have the solution in here because our setup people have done an amazing job with it and it's melting. It's melting. And so, now we will do the same thing.
Exact same thing. No difference.
For this lab will be the difference that
You have an extra
Now you
clam?
have to show this. Use different sizes.
Always being resourceful.
Always have a spare.
How many minutes?
Hey, you never know. You may just have some bad luck.
Yeah, you never know.
Based on the video, so.
And you'll be talking about
Same thing. Don't let it fall on you. Don't touch the bottom of the test tube. Warning, we have warned you now.
Don't listen to us, then you're not trying to finish it during break.
You don't want to do that. Really, it just ruins your day.
It blows.
It
No,
blows.
okay, so then you have to talk about HCl.
Okay, immersing the solution now.
How about one person does like moving showing and then
Okay, you want to put this in first.
So we talk about HCl, you show this.
Okay, start the data collection.
It's not.
Remember, you want to gently stir the solution.
Make sure you start the data collection. Because if you don't, then this would be a big waste of time.
Exactly.
Stop watching.
Hello.
Again.
So, now we have finished making this a solid solution. You want to make sure it's solid. If it's not solid, then you're wasting your data.
And time. And again, you might have to stay in a break and ruin your day. Really, it's not fun.
Yeah.
You're doing things with your life.
Yeah, like studying for AP Calc or something.
Just after that. Just after the first like that. Stop at that. We'll switch
You don't want to remove the temperature probe yet because it still has excess on it.
Same thing as before. Carefully remove the thing. Carefully.
Now you just wait for it to melt, which will not take long if you have been keeping this in a warm solution.
for this lab we'll be using different sizes.
Good. Oh, see, when you can remove this,
You should remove it and stop the data collection
wipe the excess off.
with a paper towel. Not with your hands, not with your jacket, not with your jeans.
For this lab we'll be using calcium.
Not with the chair, not with the table.
Paper towels.
The freezing point of benzoic acid, lauric acid, or citric acid, lauric acid solution can be determined by finding the temperature at which the mixture initially started to freeze. Unlike pure lauric acid, the mixture results in a gradual linear decrease in temperature during freezing.
Which we can see in this. Look at the reddish orange stuff.
Shut up!
The reddish orange.
Thank you.
Now, print a graph showing both trials. Label the graphs. And don't waste paper.
Save the environment, everybody. Save the environment.
And then we will be done.
Yeah, pretty much. You just want to save data, print, and you're done with collecting the data.
So yeah, I'll put it first one.
As you can see, we have to use the spark now.
And then the B value.
Oh, I can do it for the other graph too. I can do that now.
Can you do it for the other graph?
No, I can do it better.
I would say.
Wait, we don't pour it in first. We pour it in.
Okay.
So we're going to be reviewing what we have learned throughout this lab. The first thing that we have learned is the difference between molarity and molality. Molarity is dependent on temperature, while molality is independent of temperature. That is why we use molality for this lab. The second thing that we learned is the equation for the freezing point depression. I represents the Van't Hoff factor, and the Van't Hoff factor essentially is the number of ions a compound will separate into when it is in solution. So, for example, glucose will have a Van't Hoff factor of 1, since it is not going to separate into any ions, but NaCl will separate into Na and Cl, and therefore will have a Van't Hoff factor of 2. The last thing that we learned is how to determine the molar mass using freezing point depression. And so, using the equation that we had before, we can determine how to find the molar mass by deriving molar mass from this equation. And that's it.